Alright, welcome to Academic Digest class. Today we're treating mathematical induction. I said mathematical induction is a technique or a mathematical statement, or we use mathematical proposition. So if you don't use technique, you say proposition, used to prove statements or properties about natural numbers. Mathematical induction states that if a statement holds for a base case, usually P of n is equals to 1, then it holds for P of n equals to k and P of n equals to k plus 1. So in mathematical induction, we have three major steps. The first one is the base case, or we'll call it the base step. The second one is the assumption step, or we'll call it the induction hypothesis. Then the third step, the second step is assumption step or hypothesis induction. So the third step is to prove, which we call the induction step, and is the last part. So what we normally do here is that in this place we prove that P of n equals to 1 is true. Here we assume. Then here we get something for k plus 1. Then we show it. That is, we prove it. So we have examples here. Mathematical induction is not something you just explain. So we have examples here. The first one, they said that we should prove that 1 plus 2 plus 3 plus n is equals to n all into n plus 1 over 2. So prove 1 plus 2 plus 3 plus dot plus n is equals to n into n plus 1 all over 2 for all positive integers of n. So most of the time you're trying to prove that something happened, something is true. Even you can be asked to prove the formula for sequence and series, and you need to know something. Whenever we are doing mathematical induction, it's always maybe when a question is given to you in this order, more like a sequence, for you to prove that the three steps, that is P of n equals to 1, P of n equals to k, and P of n equals to k plus 1 is true. And you can also be given, instead of sequence, they can also give you to prove that something is divisible. But for today, we are treating when it's just in this order. We are not proving that it's divisible today. We are just trying to prove when this is equal to this side and this, left and right hand side, they are equal. That's what we are doing. So in our next class, we'll be treating when a particular value is divisible by another. So this is what we have the question. So for the first step, I'll simply say for, or you say the base case, so which is P of n equals to 1. That means anywhere I see n, I substitute 1. And when I have 1 plus 2 plus 3 plus dots plus, where I see n, I write 1 is equals to, here I have 1 into 1 plus 1 all over 2. This is the same thing as saying 1 into 2 all over 2. And I know that this is going to give me the same thing as saying, so left and right hand side is the same, is equal. So that means P of n equals to 1 is true. So let's go to the next step, which is the induction, the assumption step. So for P of n equals to k, we assume this to be true for k. So we just assume in this step. So what we are going to do is to simply say I like to solve this the way I do it. I normally focus on the n part, so I'll just say n equals to, let me write everything. This is a bad habit. I don't like writing everything the way you see it. There are cases where I have to maintain it, but I normally stick to this. Okay. So anywhere I see n now, I replace it with k all over 2. So I just assume it to true. So assume p of n to be equals to k, and that is true for k. So I assume it to be true for k. So for the next step, which is for p of n equals to k plus 1. So it has 3 basic steps. And this is what we call the induction step, where you prove. And what are you proving? What you are proving is simply write that thing that you are given. N is equals to n into n plus 1. Notice my voice changed because this is where everything is most important. Very important. So where you see n now, do k plus 1 is equals to k plus 1. Where you see n, k plus 1. Then notice that I have plus 1. So very important. This is now all over 2. So k plus 1 is equals to k plus 1 is equals to k plus 1 into k plus 2 all over 2. So notice that for k plus 1, I replace this with k plus 1, k plus 1, k plus 1, 1. You see this thing you have here? See this thing you got here? This thing you got here? This is what you are going to prove. So now that we've gotten this, we now show that we need to show that k plus 1 is true. Very important. I've seen sometimes they mix it up, doing all those confusing things, but you need to do it in such a way that you get for k, then get for k plus 1. Then once you get for k plus 1, you need to now go back and prove this. And how do you prove it? You prove it by doing, if p of k, if k is, for example, 2, k plus 1 is the same thing as saying 2 plus 1. Are you seeing it? Which is going to give you 3, then 2. Are you seeing it? So inside k plus 1, you have k. So for this reason, this principle now is what you're using. Just like if I have 2, 3, the next number after 3 is 4, and inside 4 we have 3 plus 1, which is 4. So we need to use this same principle to say, since k plus 1 is the same thing as saying k plus the next term, it is the same thing as saying go to p of k. What you got for p of k, in order to prove this, what you got for p of k, plus the term that you got for k plus 1. That is what you are using to prove. So notice that here, k, p of k, what I got for p of k is this thing. So I'll come and write it here. I'll come and write it. Remember what I got for p of k is this. I'll come and write it here. K into k plus 1 all over 2. All over 2. These are the questions. Don't get confused by that question. So now let's check for k itself, that is for k plus 1 plus, then k plus 1, what is the value you got for k plus 1? That is when you substituted for k plus 1, what did you get? So see, this is the k plus 1 term that is here. This is the k plus 1 term. Remember that we use this k plus 1 and we got this. This is what we are proving. So we always do it now. This will now be plus k plus 1. So this thing, everything on the left hand side should equal to what you have, what you got for this. If you like, don't understand. I've told you, whenever something like this is going on, there's a level of attention you need to apply. It's not something you look at one way. So now that I have this, we don't do Induction here. Pay attention. So if I know this, I will now have this thing. Anytime I have this, you notice that this thing I can take the LCM of this. And if I take the LCM, it will give me the sentence as saying k into k plus 1. Okay, let me do it this way. All over 2 plus, remember that this one is over 2, plus k plus 1 over 1. This will simply give me k into k plus 1. And this one will simply give me plus, when 2 divided by 1, it will give me 2 into k plus 1. Now remember that everything is over 2. That's over 2 everything. Let me just write it here. I want to leave it here. Remember that anything over, if you have this way, is f times this and then 2 under. So this is going to give me the sentence as saying, let's look at it. And you need to be trying your best to see that you are looking at what you're doing here. You need to be checking to see that what you're doing here, that is tallying with it. That is tallying. So you remember that the whole thing you're getting should be equal to your right hand side, k plus 1, k plus 2. Once it's equal to your left hand side is equal to your right hand side, you've proved it. So notice that I did this way. I can now collect line 10. So I can now say k plus 1 is common. I bring it out. Then I have k plus 2. Then remember I have 1 over 2. And this is the sentence saying k plus 1, k plus 2, all over 2. So you see that it is equals to my right hand side, because this thing I have here is the sentence saying 1 over 2, k plus 1, k plus 2. So k plus 1, k plus 2, all over 2. If I don't use QED, I can just say proved. Quite easily done. Okay, so this is for question 1. This is how you go about it. So let's go to the second question. So as we solve more questions, you understand better. So the second question says prove that 1.2.3 plus dot. Once I see this kind of extensive grammar, I normally overlook it. I just focus on the place they have n. I know there are some questions that is important to pay attention, so you can carry everything along. But for me, I just take the n. In as much as when some people are doing this, or maybe some textbooks are doing it, it looks as if everything is dependent on the p of n equals to 1. But once you're able to get p of n equals to k, and you follow the steps I'm giving you, you will always be able to prove it. So is equals to 1 over 4 n plus 1, n plus 2, n plus 3. Just master how I'm doing it. Once you know how I'm doing it, any question they give you, just use the same method. It will always work. I don't teach like what I've not made thorough research on. So it will always work once you follow this principle. So this is the question 2. We are proving that f is equals to, for all n elements of natural number. So let's do it here. So for n, p of n P of n equals to 1. For P of n equals to 1, I will have 1 into 1 plus 1. And everything here is going to give me 2 into 3 into 1, which is going to be 6, equals to 1 over 4 into 1 into, remember what we are doing for P of n equals to 1, which is the basic step. We are trying to make prove that if 1 enter everything here, that left and right hand side will still be equal. Remember what we are still doing is for induction that has to do with proving left and right hand side to be equal. We'll still do when we are proving that it's divisible. So this is 2, this is 3, this is 4, this is 1. So if you check this, multiply everything. If you multiply everything, you should get 2 times 3, 6. 6 times 4, you get 24. But remember that this can take care of this. So you just have 6. So proved. Or you say, instead of proved, we just say P of n is true for n equals to 1. You can say P of n is true for n. P of n is true for n equals to 1. Now let's go to the second step, which is the assumption step. For n, P of n equals to k, we assume k to be true for, let's substitute. So where I see n, where I'm having n, I have k into k plus 1 into k plus 2 equals to 1 over 4k into k plus 1 into k plus 2 into k plus 3. Now that we know this, we've been able to replace this. So once we do this, we just assume it to be true. We don't do any other thing, we move. But notice, everything about my P of k, this thing now, is the P of k value. And I'm saying that is equals to what I have here. That is equals to what I have here. And I'm assuming it true. So by assumption, I'm assuming it true by assumption. So now for P of n equals to k plus 1, I'll simply go anywhere I see n, I put k plus 1. So k plus 1, I'll have k plus 1, then k plus 1 plus 1, then k plus 1 plus 2 equals to 1 over 4 k plus 1, k plus 1 plus 1, k plus 1 plus 2, k plus 1 plus 3. So anywhere I see n, this is n, this is n, this is n, this is n. Anywhere I see n, I replace it. So once I'm through with doing this, I can now come and start doing k plus 1 into k plus 1 plus 1, 2 into k plus 3 is equals to 1 over 4 k plus 1, k plus 2, k plus 3, k plus 4. You see this thing I have here? This is what you will now show. So we show that we need to make sure that We are now showing that this thing is true. We show that what we have here on the right hand side, K+1, is true. So this thing we have on the right hand side, that's what we need to show. And how do we show it? We will use pk plus K+1 term. And what is K+1 term? That is pk. First of all, this is our pk, the one we got by assumption. We'll bring it plus K+1 term is simply everything here. This is K+1 term. Everything here is K+1 term. That is what gave us this. So we'll bring down K+1 term. So let me bring it. I'll have P of K, which is this 1/4. Remember I told you if I have 3, I have plus 3 plus 1, which is 4, equals to the next term. So for that reason, if I get P of K, I will do P of K come down, then I'll do the thing I use to get the next term. That is what I use. So I will use whatever I get here and whatever I have here to prove this thing. So I have so see, I have and everything I'm doing here should equal to this. Once it's equal to it, I have proved it. So for that reason, I need to make room. I don't want to write it down. I don't want to bring this down, but you can still bring it down. 1/4 K+1, K+2, K+3, K+4. So if I know this, I will now have right here. And I have right here on the left hand side, I have everything down here. Okay, see, remember that I have P of K to be, you moved and stopped at K+3. That means after K+3, the next thing separating it is plus. Then I get the term, the K+1 term, which is this. This is K+1 term. This is P of K. This one, everything. That's what I brought it. So K+1 term, brought it. So you can see that if you remember in mathematics, let's say I have, let's pay attention. Let's say I have 1 minus 2 times 3 plus 1 minus 2 times 4. This thing is the same thing as just saying 1 minus 2, 3 times 4. This is 12 times minus 1, which is minus 12. And if you do, this is minus 1 times 3, minus 1 times 4. By the time you do it, it will still give you minus 12. So you need to use this approach. Once I see the same value this side, and it's being separated by a plus sign, and there's multiplication, something I'm multiplying to it, I simply factor out and carry just one of it. I don't need to carry the 2 of them. So why did I show you that? Let's come here because we'll make use of such knowledge. Notice that right here LCM can have its effects, and this thing is separated by a plus. So I want to say this right hand side, what am I seeing? I'm seeing K+1. This side, what am I seeing? I'm seeing K+1, K+2, seeing K+2, K+3, seeing K+3. Now let's see. Once there's something multiplying this side and something multiplying this side, I don't need to be carrying all of them together. I'll just factor out. So by LCM, this will be 1/4 to everything. Then I'll have K into K+1, K+2. I'm focusing on the left. The right hand side is to be proved. I don't need to look at it till I prove. k plus 3. Then plus, if you take LCM, 4 will come here. So I have k plus 1, k plus 2. Somebody will still want to ask me, how did you do that? Notice that this thing is the same thing as saying k into k plus 1 into k plus 2 into k plus 3. Then plus k plus 1 into k plus 2 into k plus 3. Then notice that everything this side is divided by 4, which means that this side is divided by 1. The LCM is 4. 4 into this will be 1 times this, it will be k into k plus 1, k plus 2, k plus 3. Then plus 4 divided by 1, 4 into k plus 1 into k plus 2. There is no cramming in this thing. It's very easy once you learn this method I'm using, because I've seen most students always confused. So you see that 4 is on the divisor. So I can just say, instead of carrying it up and down, I can just say bring it out to one side, 1/4. Then do everything I'm doing. So it's the same thing with what I have here. Why I did it is because see that this one is this way. So, and as I've done this now, it's now easy for me to start factoring out. Notice that I have k plus 4. I have 4 outside. I have k outside. Then I have k plus 1 this side, k plus 1. I have k plus 2 this side, k plus 2. I have k plus 3, I have k plus 3. So what you just need to do is carry each of them, carry one of it. Just bring this one out, k 4 and k plus, because these two, I have this. If these 4 and this come together, I have k plus 4. Then factor every other thing out 1. Then remember that everything here is being divided by 4. Or you say 1, or you just bring down this. So this is now equals to the right hand side. Notice that the right hand side is k plus 1, k plus 2, k plus 3, and k plus 4. Because by the time you use this, k times k plus 1, k times k, that is, this k times everything here will give you this. And you see the k. Now this 4 times this will give you everything here. And when it gives you with the plus, you see that everything on this 4 side will still move this way, and everything on the k side will still move this way. So that is how we got that. So 1 is equals to 1/4 k plus 1, k plus 2, k plus 3, k plus 4. I started it with k plus 4. This thing is distributive, associative. So if k plus 4 is here, it can also be here. So they are equal all over 4. Proved. Very simple. So let's move to the next question. Let's move to the next question. There's so much air here, so I'm trying to make sure that we manage time and we control the papers well. So the next question, question 3. Prove that 1 plus 3 plus 5 plus ... plus 2n minus 1 is equals to n squared. So we have, like I told you, I don't like carrying all those 1 plus 3 plus. I just focus on the one that has the variable 2n minus 1 equals to n squared. So for the first step, the base step, so p of n equals to 1. I will have 2 into 1 minus 1 equals to 1 squared. So 2 into 1 is 2 minus 1 equals to 1. 1 raised to power anything is 1. So this is 1 equals to 1. So p of n is true for n equals to 1 for the base step. So for P of n equals to k. Let's try to prove. So I have 2, let me do it here. I have 2k minus 1 equals to k square. So I assume P of n to be true for n equals to k. So I just assume it. But notice something. Notice that P of k has given me this. This is what I will use on the left hand side with the next term. So for P of k plus 1, that is for P of n equals to k plus 1. What is this one now? For Pn equals to k plus 1. So I'll simply have, instead of 2k now, notice that this is 2n, shebi? So I have to be very careful. 2n is essentially saying k plus 1, n, then plus 1 is equals to k plus 1 square. Whatever we get here, this is what we are going to prove. This is what we show. We have to show that k plus 1 is true. So we have to show that k plus 1 is true. That is, we need to prove that this thing we have here is true. And what do we use in proving it? Notice that what we have here is simply 2 into k plus 2. Okay, and notice that what we have here is minus, not plus. So minus 1. And this is something that's saying 2k plus 1 is equals to k plus 1 square. So this thing that we have here is what we are proving. So we show that k plus 1. We show that k plus 1 is true. What do we use in showing it? We will use k plus 1 term and k. So this is something that's saying I have 3. The next term is this one. And the next term gave me this. So I need to prove this is true. So let's get the term P of k. He gave me P of k plus 1. Give me k plus 1 square. So I need to use it to prove it. So I'll bring what P of k gave me, which is k square. And k plus 1 gave me 2k plus 1. So I need to use it to prove that my left hand side is equal to my right hand side. So whatever I do in the left hand side should equal my right hand side. Once you're able to remember this thing in our group, so it's just the sentence saying I have, for example, 2. Then I bring 2 plus 1. It come and give me 3. I want to prove it on this side that what I have is equal to this. So that is what we are doing in mathematical induction. So when is divisibility? The next class will still teach you how to go about that. So this is going to be the sentence saying k square plus 2k plus 1 is equals to, this is going to be k plus 1. That is k plus 1 square. And this is the sentence saying k square plus k plus k plus 1. K square plus 2k plus 1. So this is equals to k square plus 2k plus 1. Or we can say that this thing now, by the time you factor it out, this thing should give you what is common between these two. You see that k is common. K is common. That is using LCM. Using factorization, k is common. So I now have k plus 1. Then I also have plus 1 into k plus 1. So if you do this very well, you see that you still have the same thing as k plus 1, k plus 1. So whichever way you want to use, but you see that it's the same thing. Very, very the same thing. Alright, so let's analyze what we've done. Now let's move to the next question. Next question says, it says, prove, yes, let's check the one we just finished. Okay, it says 1 plus 2 plus 2 square plus, shebi, yes, plus 2n raised to power minus 1 is equals to 2 raised to power n minus 1, that we should prove it. So with the same bad habits, I will still just come and carry just this and this. I don't look at this. Some people look at this, speak many grammar, but I don't look at it. I just look at this. But in your exam, you look at it, so you don't have issue. This is 2 raised to power n minus 1 is equals to 2 raised to power n minus 1. So this is down. This one is raised to power. Don't mix it up. Alright, now this is going to be the same thing as saying for p of n equals to 1, I will have 2 raised to power 1 minus 1 equals to 2 raised to power 1 minus 1. And this is going to be 2 raised to power 0. It's going to be 2 raised to power 1 is 2 minus 1. This is going to be anything raised to power 0 is 1 equals to 2 minus 1 is 1. So that means that p of n is true for n equals to 1. Now, for p of n equals to k, I will now have 2 raised to power k minus 1 is equals to 2 raised to power k minus 1. So I assume p of n to be true for n equals to k. So notice p of k gave me this. So for p of k plus 1, or you say for pn equals to, for pn equals to k plus 1 equals to k plus 1. Irritating. So I will now have, where I see my, remember what I have, what I started with the question. So 2 raised to power n. So I will have, let me write it, 2 raised to power n minus 1 equals to 2 raised to power n minus 1. So I will have 2 raised to power the k plus 1 term, raised to power k plus 1 minus 1 is equals to 2 raised to power k plus 1. Anyway, I see and I replace it with k plus 1 minus 1. So I now have, this is something I'm saying 2 raised to power k, 1 minus 1 is just 0. So 2 raised to power k is equals to 2 raised to power k plus 1 minus 1. This thing you have here is what you are proving. So we show that k plus 1 is true. Or is the value we got for, that is pk plus 1, the value we got for it is true. So how do we do that? We simply make use of p of k and then the p of k plus 1 term, which is this. If I have 3 plus 1, it will give me 4. So for example, if I have 6 and the next term is 7, so 6 plus 1 is 7. It gave me 7. So when I want to prove this 7 that is here, I need to make use of this and this to prove it. This is p of k. This is p of k plus 1. So or you say this is k plus 1. So I just come to prove it, I just do p of k plus k plus 1 is equals to what I have on the right hand side, which is 2k plus 1 minus 1. So P of k is this 2 raised to power k minus 1. Then k plus 1 term is plus 2 raised to power k is equals to, it should equal the right hand side for it to be proved. So notice that this thing now that I have here, right hand side, first of all, let's look at it. This right hand side is the same thing as indices, because this thing indices says that this is the same thing as saying, when I have the powers added up, this is the same thing as saying 2 raised to power k times 2 raised to power 1 minus 1. Indices, if you remember. So give me this. So this thing is also this thing. So notice that this side, I have 2 raised to power k, 2 raised to power k. This is the same thing as saying 2 raised to power k plus 2 raised to power k minus 1. And notice that this thing I have here, is the same thing as saying 2 into 2 raised to power k minus 1. And notice that this is also the same thing as saying 4 raised to power k minus 1. Whichever way I want to see it. So notice that right here, if I have x plus x, is the same thing as saying 2x. So this is going to be the same thing as saying, since I have 2 raised to power k and 2 raised to power k, this is the same thing as saying 2 into 2 raised to power k. That is 2 raised to power k in 2 places minus 1. And notice that it's looking exactly like what I have here. Looking like this. Or you can even say this power is having 1. So you can see that this is equals to what you have on the right hand side, which is 2 raised to power k plus 1 minus 1. Because since these two now are in this way, this is like multiplication. This is the same thing as saying add the powers. So you see that it's the same thing with what you have here. Please note that k plus 1 and 1 plus k is the same thing. So this is your answer. You've proved it. So come and write proved. Or you write QED. Quite easily done. Alright, so let's look at the second to the last question for today. So I have for all n greater than 1, prove that 1 square plus 2 square plus 3 square plus ... plus n square is equals to m plus 1 whatever. And like I told you, I have that bad habit of not writing everything. I just carry the part that has n. So I'll just come this side. Where is n? Just this one, n square. I'll carry it, n square equals to n plus 1 into 2n plus 1 all over 6. So I'll simply do, for the base step, for p of n equals to 1. I'll have 1 square equals to 1 into 1 plus 1 into 2 into 1. Even if you do this and it doesn't work, you can still get it using this method I'm teaching you. Even if 1 does not prove it. But it is proper that 1 proves it according to the law. If it doesn't prove it, it means it's not correct. But I tell you, if you use this method, once you're able to set your P of K upright, it will always be correct. You always get the final answer. All over 6. So notice that this is 1 plus 1, 2. 2 plus 1, which is 3. This is 3 here. This is 2 here. All over 6. When you learn this thing where you become very fast and rough, you don't really care. So 1. So equals to 1 square is 1. So 1 is equals to 1. So P of n is true for n equals to 1. So for the second step, for the for the assumption step, we do for P of n equals to k. I'll simply have k square is equals to k into k plus 1 into 2k plus 1 all over 6. So this is our value for P of k, which we will use with the next step. So k plus 1, 2k plus 1 all over 6. Alright, so let's progress this place. Let's continue this one. So we just say assume P of n to be true for k, just like that. So for P of n equals to k plus 1, we'll simply do that part that we have k plus, that is the n, this part we have k plus 1 square is equals to, anywhere I see n, I put k plus 1, k plus 1 into k plus 1 plus 1 into 2 into k plus 1. You need to be cautious when you have something like this, plus 1 all over 6. So now that you have this, notice something. This is going to be the same thing as saying k plus 1 into k plus 2 into 2k plus 2 plus 1. This is the same thing as saying k plus 1, k plus 2, 2k plus 3, and divided by 6. So you see this thing that I have here, and this value, this is my P of k, and this is my k plus 1 term. That is the next term. It's just like when I have 3 plus 1. This thing is like 3. This thing is like 1. And it gave me this. That is k plus 1. It gave me this. So this thing that I have here is what I'm proving. This thing that I have here is what I'm proving. So I will simply say, show that k plus 1 is true. So this thing, k plus 1, k plus 2, 2k plus 3 over 6. That is what I'm proving. So it simply means that I will now have down here P of k plus 1 equals to k plus 1, k plus 2, 2k plus 3 times 1 over 6. I want to use this. I want to use it this way, 1 over 6. So P of k is simply this. So it's still the same thing as saying 1 over 6 k into k plus 1, then 2k plus 1, then I have k plus 1. The term for k plus 1 is k plus 1 square. So plus k plus 1 term, which is this, k plus 1 all square. And this is equals to the right hand side, which is this side, the parts that we are proving. So everything, by the time we do everything here, it should be equal to this thing. So this is the same thing as saying 1 over 6 k plus 1, k plus 2, k plus 3. So let's try to simplify and see what we have. So notice that I'm being fast. You need to be the one paying attention, putting effort and paying attention. Alright. So this is going to give me Let's try to look at this. Okay, let's do the LCM. If we do the LCM, we see that this side is the owner of this 6. This is the sentence saying k into k plus 1, 2k plus 1 over 6 plus k plus 1 square over 1. So this is going to give me 6. So I have k into k plus 1, 2k plus 1, then plus 6k plus 1 square equals to my right hand side. I will not carry this thing down again. I don't like carrying it down. It's what we are proving. I don't have to be carrying it down. So I have this. So notice that this is the sentence saying what is common to this. See, I have k plus 1 here. Then notice that there's a plus sign here, shall we? So let me bring that k plus 1. If I bring this k plus, if you don't want to do it this way, you can simply do expand this thing. You do k plus 1 times it, then times it with 6, then times this side, divide everything. If you do it to this side, it will be equal. But I just want to do my mathematics because I know it, and you need to learn it. So I have k plus 1 is here, k plus 1 is here. I bring it out. The minute I bring it out, I'm left with k, then 2k plus 1, then plus 6k plus 1 all over 6. 6 times k plus 1. If this k plus 1 times this, it will still give you this thing. And if this k times this, it will still give you this thing. And if this 2k plus 1 times this, it will still give you what you will have from timesing this. So it's the same thing. I just factored out the k plus 1 because this times k and times k plus 1 is the same thing as k plus 1 times k plus 2k plus 1. And this k plus 1 that is here, this k plus 1 that is here, notice that everything that's this k plus 1 that is here can still come and times this, and it will give you this. Remember that is plus that is separating them. So if I know that if this times this is everything here, but if this will confuse you, let's go and do it the way I like, the way I know you like things. So on your own now, you can go ahead when you progress and learn this method. So let's go to the method I know you like, one that will not give you stress, the secondary school pattern you know. So let me rewrite this. Going about this the way you know, this will simply be k plus 1 square is the same thing as saying k plus 1 into k plus 1, which is the same thing as saying k times k square is k plus k plus 1, which is the same thing as saying k square plus 2k plus 1. And notice that everything is being times by 6 plus 2k plus 1. Then k times k will be k square plus k. Now k square times 2k will be 2k cube. Then k square times plus 1 will be plus k square. Now k times 2k will be plus 2k square. K times 1 will be plus k. And notice that everything is being separated by 6. Now 6 into k square will be 6k square plus 12k plus 6. Still separated with this b plus. Alright, see what we've done. You see, I wanted to factor out, but I said let me show you this before going to factorial, so you don't think maybe we are doing manipulation. It's still the same procedure. So now that we are done with this, let's check. 6 multiplied this, multiplied this, multiplied this, and you have this. Now k multiplied this, and you have this. Then k again multiplied this, you have this. K square multiplied this, you have this. K multiplied this, you have this. Then multiply this, you have this. You have this. So add up, you have 2k. Okay, you have 2k3. Then k square, 6k square. How many? 2k square plus 1k square is 3k square. 3k square plus 6k square is 9k square plus 9k square. So we've collected the k squares. So it's remaining k and k. So k plus 12k is plus 13k. Now plus 6 is equals to, let's check the right hand side. Let's check our right hand side to see if it's true. So our right hand side, we have right hand side 1 over 6 into k plus 1. So into k plus 2 into k plus 3. Let's multiply. This k plus 1, k times k is k square. K times 2 is plus 2k. 1 into k is plus k. 1 into 2 is plus 2. We'll bring down k plus 3 so that we'll continue to stress ourselves the way you understand it. I know you. You like it like this. Once it's factoring, you start complaining. So see, I bring this. Then brought this one down. Let's go again now. Case. Remember that everything we have here, remember that everything we did here up here is carrying over 6. That's why I normally say bring down that 1 over 6 instead of doing over 6. So I bring down my 1 over 6 so I don't get confused. I bring it down. Everything we did up here, look at it. Then remember it's carrying over 6, so bring it down. So let's go. K squared times k is going to be k3. K squared times 3 is going to be plus 3k squared. Now, okay, we are done with k squared. Plus 2k times k will be plus 2k squared. 2k times 3 will be plus 6k plus k times k plus k square. K square. K times k is k square. That is k times k, k square. K times 3 plus 3k. Now 2 times k plus 2k. 2 times 3 plus 6. So this is going to be the sentence. And let's collect the k3s. Let's collect the k3. Where are the k3s? Remember here we got, here we did, yes, here we did k squared times 2k, we got 2k3. So here let's check if our k3 is up to this. I have 2, 2, 2. So I have 1, 2, 3, which is 3 plus 5, 6, 7. Something is missing. There's something we did not do right. Okay. Yes. I'm the one that caused it. What we are trying to balance, what we are trying to prove is this. On the right hand side is this. K plus 1, k plus 2, 2k plus 3 over 6. I don't know what witchcraft brought about this thing. So this is not what we are trying to prove. Guys, the right hand side is that thing that we got now, that we say that we are proving, which is this. So this is it. K plus 1, k plus 2, k plus 1, k plus 2, then 2k plus 3, 2k plus 3 over 6. This is what we are proving. That's what is on the right hand side. I think I made mistake and copied something from here down here, which is not proper. So if you like, you're thinking many things. Equals to, so divided by 6. And remember I told you this divided by 6 is 1 over 6. So let's go. K times k plus 1 times k plus 2 is going to give me k square plus 2k plus k plus 2. Should be k square 2k k 2. So we'll bring down 2k plus 3. So this is going to give me 1 over 6 k times 2k will be 2k square, 2k cube, 2k cube. Then k times 3 will be plus 3k square. Then 2k times 2k will be plus 4k square. Then 2k times 3 will be plus 6k plus, then okay, 6k. Then okay, we are done. K times 2k will be plus 2k square. K times 3 will be plus 3k. Then 3k. Then 2 times k is going to be plus 4k. Then 2 times 3 is going to be plus 6. So notice that this is going to give me the sentence in 1 over 6 2k3 k square k square k square. So 7, 8, 9, 4, 5, 6, 7, 8, 9 plus k. So this is 9, 13. That is 6, 7, 8, 9, 10, 11, 12, 6. What am I doing? 6k, 6k plus 3k, 9k, 9k plus 4k, 13k, then plus 6. So you can very well see that what I have on the left hand side is equals to what I have on the right hand side. Proved. So there you have it. In our next class we are going to be doing induction. Prove induction by divisibility. That's to prove that an induction case is divisible. Questions that has to do with divisibility. So remember, we could have factored out. So the assignment I want you to do for me now is try to use factoring out method to do this. At the point where we got to this, we could have said 6 times k will give me 6k plus 6. Then we'll do 2k times k square plus k. By the time we do it, we multiply it. You see that the next one now is now to say, how do we do about this k plus 1 that is here? And this k plus 1 that is here can easily multiply what I have here. Then we add up. If we add up, it should be equal to this when you do the same thing. So thank you. Subscribe to the channel.